I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll have a fresh look at rational functions of the form ax plus b over cx plus d, quotient of linear polynomials. Well, we have been uploading videos for you since last 15 years and now we have crossed 20,000 videos. I'm really thankful to all the viewers and subscribers for watching these videos, providing excellent suggestions, and keeping us on the track of providing the best. Sharing the passion has brought me so close to all of you globally. Now let's look into the contents of what we are going to cover in this particular video. We have a rational function, as you can see the graph of, and normally any linear quotient rational function will have a very similar graph. The only thing which is going to change mainly is the horizontal asymptotes and the vertical asymptotes. Of course, some transformations will make these curves go through different points. However, shape is going to be exactly same. So once you understand the basic concepts, you are in a position to answer each and every question based on the quotient of linear polynomials, the type of rational functions we are discussing now. We will discuss how do we find y-intercept, how do we find vertical asymptote, how do we find horizontal asymptote, how do we define the domain and range of these rational functions, figure out the increasing, decreasing intervals, positive, negative intervals, and graph the function. Not only that, from the graph, how do we find the equation? That also we will cover. Feel free to contact me on the email address given and master this subject, as many students have done before.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is ax+b.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now let's look into some of these important characteristics one by one. So, what is an x-intercept? X-intercept is a point where the graph crosses the x-axis. In this particular case, the point shown here is the x-intercept. What is the y-intercept? Y-intercept is a point where the graph crosses the y-axis. Vertical asymptote. Vertical asymptote is a discontinuity shown here in the graph with this orange dotted line. So that horizontal line, which in this case is x equals to 3, is a vertical asymptote. The horizontal asymptote is the horizontal dotted line shown over here, which in this particular case is y equals to minus 3. Domain and range. Rational functions of this form will always have restrictions, and in this particular graph, we can easily see that the domain does not belong to 3 and the range does not belong to minus 3, but otherwise all other real numbers are in their domain and range. So I think we have analyzed the graph clearly, but let us see from the general equation how do we calculate these parameters. Let's begin with the x-intercept. Now, if a general equation is given to you, let me rewrite this equation as y equals to ax plus b over cx plus d. We're talking about x-intercept. So you understand x-intercept means y is equal to 0. Now to make y equals to 0, let's write it first. What do we get? We get 0 equals to ax plus b over cx plus d. Now the numerator should be 0 so that the whole function is 0, right? So we can equate ax plus b to 0 and find the value of x. That is how you find the x-intercept. Is that clear to you? So we can rearrange, and then we have what? Ax equals to minus b, and that gives you the value of x as equal to minus b by a. And therefore, we can now write the x-intercept for this particular function, which is in coordinate points, x-intercept will be what? X value being minus b by a, and y value, of course, will be 0. Is that clear to you? These are simple steps to follow and get x-intercept for any function for that matter. Numerator equals to 0. Clear? So let's write a note here. For x-intercept, numerator equals to 0. Now let's go for y-intercept. So when I say y-intercept, that is to say, where will the graph cross the y-axis, right? That is the y-axis. So in that case, x value is 0. So for this, x value is equal to 0. Equating x to 0 in the equation, y equals to ax plus b over cx plus d gives us the y-intercept. So if I equate x equals to 0, what happens? Very clearly, we get y equals to a times 0 plus b over c times 0 plus d, and that is the ratio b over d, right? So that becomes the y-intercept. So this point here on the graph is basically from the equation b over d. You get the idea, right? So that is why we are showing all this. So coordinate point for y-intercept will be x value being 0 and y value being the ratio of b and d, right? So this particular ratio, that is y-intercept. Is that clear to you? Now let's look into the vertical asymptote. Vertical asymptote, as I said, is this particular line. So this is your vertical asymptote, right? I'm writing VA for vertical asymptote, and that is a restriction on the domain of the function. How do you find vertical asymptote for an equation given as y equals to ax plus b divided by cx plus d? We are working on a general equation so that when the values are given to you, in that case, you have no difficulty in finding the result. So that really means that denominator is 0, right? So for vertical asymptote, cx plus d should be equal to 0, right? Because that is a restriction, denominator equal to 0. So you can solve for it. Cx equals to minus d and x is equals to minus d by c. So we have the vertical asymptote as x equals to minus d over c, right? So this ratio, right? Do you see this? This equation. These two are the critical things. So basically what we have to do, we know the restriction that denominator is not equal to 0. So that gives us the vertical asymptote, right? So to find vertical asymptote, equate denominator to 0. Is that clear to you? Now let's look for horizontal asymptote. Now horizontal asymptote in this particular case is this particular line, which is y equals to some value which the graph approaches. So we define this as if x approaches positive infinity and y approaches a value L, in that case the horizontal asymptote will be y equals to L. Also, if x approaches minus infinity and y approaches some other value, let's say k, then the horizontal asymptote will be y equals to k. Well, in this case, L and k both are same, but in some rational functions, it could be a different value. You should explore and figure out what kind of rational functions are those. Okay, now let's see how do we find the horizontal asymptote in this case. So we have y equals to ax plus b over cx plus d. Now to find the horizontal asymptote, we can factor x out, right? So I could write this as taking x common, a plus b over x. Do you see that? This is a strategy. So we'll take x common and we can write this as c plus d over x. Perfect. So once we do that, we can cancel these x's. So we get what? We get y equal to a plus b over x over c plus d over x. Now see what happens when we say that x approaches a large value, let's say positive infinity. In that case, what will happen to b over x? Well, that will approach 0 and d over x will also approach 0. Do you see that? So these values, they approach 0, right? So we can ignore them since they are approaching 0. And that results into y equals to a over c. So that becomes the equation of horizontal asymptote. You get the idea. So horizontal asymptote will be y equals to a over c for the general equation we are talking about. You get the idea, right? Now you can see, in this case, we know that the equation is y equals to minus 3. If I know that the ratio of a over c is minus 3. You get the idea. Earlier, we found the vertical asymptote and we again found the ratio. So you get an idea. From this case, we are in a position to find the equation of the graph. So the risk ratio a over c is what we are looking for when we talk about horizontal asymptote. Now, let's look into the domain of this particular function. So when I say domain and range, so let's talk about both domain and range. So domain is possible x values, means except for the vertical asymptote, right? So we know that the denominator cx plus d should not be equal to 0, right? As far as the domain is concerned. And thus implies that x should not be equal to minus d over c, which is our vertical asymptote, right? So we can write the domain for this particular function in general as x belongs to real numbers where x is not equal to the ratio d over c. Make sense? Now how about range? So range is the y values which the function can take. Now, it cannot take the value of this horizontal asymptote as you are seeing, correct? So horizontal asymptote was what? Horizontal asymptote was a over c, this ratio. So the range is y belongs to real numbers where y is not equal to a over c. You get the idea, right? So for a function we have in discussion, the quotient of linear polynomials, the horizontal asymptote leads to a restriction on range, right? So this is restriction on range. You see that? So that is restriction on range. Perfect. So that is how we have seen this. And the vertical asymptote is a restriction on domain, right? So this is restriction on domain. Perfect. So I hope these points are absolutely clear. So are you there with me on this front? So based on the given equation, which we have under consideration, ax plus b over cx plus d, we have defined all the characteristics, correct? So now you can see, you know how to calculate the y-intercept, vertical asymptote, horizontal asymptote, domain and range. Perfect. For the given equation. So that is kind of complete concept. Now, let us analyze the graph. And from the graph, we'll figure out the other two things. So now we'll do graph analysis. So once you sketch the graph, it may be something like this. Let us say this graph is given to you. In that case, my question now is, find the increasing and decreasing interval. So you have to check a graph from left to right. Do you see that? Always read graph from left to right. Perfect. So we see this is always increasing in its domain. Do you see that? So increasing interval will be what? Increasing interval, let me write in short form, will be from minus infinity to the restriction. Do you see that restriction? In this case, the vertical asymptote is what? Vertical asymptote is y equals to 1, 2, 3. So it is increasing from minus infinity to 3 and then from 3 to infinity. Do you see that? And how about decreasing interval? None. So you will notice that these type of graphs are always increasing or always decreasing, except for the restriction, of course, which is because of the vertical asymptote. Perfect. Now the other parameter which is normally looked into is, where is this graph of the function f of x positive or negative? So when I say positive, that means what? Positive means that the value of the function is greater than 0. That means it is above the x-axis. So from the x-intercept, check the x-intercept for this. And then answer the question. So here, the x-intercept is at 2. And therefore, we can see from the graph that it is positive after 2, but between 2 and 3, right? Because this line is x equals to 3. So it is increasing from 2 to 3. You get the idea. And how about it is positive in this interval? Other interval, it is negative, right? Negative means that the value of this function is less than 0. So it is from minus infinity to the x-intercept, which is at 2, and then from 3 to infinitely large value. Since we have the horizontal asymptote here, which is y equals to minus 3. So it is negative all throughout. Is that clear to you? Perfect. So we have seen how do we define increasing and decreasing interval from the given graph. Now, let's get back to the last question, and which is, how do we find equation of the graph? So this is very critical. We need to find the equation of the graph of rational function, and in this case, it is of the form ax plus b over cx plus d. Now, to define this equation, couple of parameters are very critical, which we just saw. So one of them is horizontal asymptote, which in this case is what? Well, horizontal asymptote is here y equals to minus 3. Now, horizontal asymptote is ratio of a and c, right? So we know that horizontal asymptote is y equals to minus 3, and that should be equal to a over c. You see that? The second parameter to look into is the vertical asymptote, which is right here. So the vertical asymptote is at x equals to 3. Now vertical asymptote gives you a restriction in the denominator, right? So we analyze the vertical asymptote and we know vertical asymptote is at x equals to minus d over c, and this value given to us is 3. We can also look into x and y intercepts. The x-intercept in this case is at 2. So this is your x-intercept at 2, right? X-intercept is the value where the function is 0. So that 2 gives you the equation numerator ax plus b equals to 0 at x equals to 2. You get the idea. So if I substitute 2 here, then we get 2a plus b is equal to 0. Correct? From y-intercept, which is at x equals to 0, you get b over d equals to minus 2. Now once you have related all these parameters, it should be very easy for you to find the equation of the graph. I'd like you to pause the video at this stage, answer this particular question, share your equations in the comments. Correct? So I'll leave this exercise for you and then we'll take this solution in another video. Please try to solve this and write in comments the equation of this graph. Perfect? So with that, we come to an end to this particular exercise of finding parameters and characteristics of rational functions of the form ax plus b over cx plus d. I hope you find it interesting and useful. Feel free to contact me on the email address given to learn and succeed. You can always like and subscribe to my videos and keep sharing. Thanks for your time and all the best.